So now we want to talk about some redox reactions, and I've written 3 redox reactions already out on this page, so let's get right at it. First thing we have to do is assign oxidation numbers to everybody in the reaction. So the top reaction that we have here, magnesium is by itself, all by itself. That means its oxidation number is, drumroll, 0. Oxygen is also all by itself here, just gaseous oxygen molecules, and so since they're all by themselves, their oxidation number is also 0. When they get into the compound, however, when they react with each other and form a compound, magnesium is now an ion, and it will be a 2+ ion, so its oxidation number is +2. And oxygen has turned into oxide, which is a 2- ion, but now it's a -2 for our oxidation number. By the way, this is not a balanced reaction, so maybe we should balance the equation here. We had 2 oxygens. Why do we have 2 oxygens? Because the oxygen is diatomic when it's by itself. So we need 2 oxygens on that side and 2 magnesiums on that side, and then we're good. Right. So back to redox. We need to decide who has changed oxidation numbers. The magnesium has gone from 0 and become a +2. That's change. And oxygen was a 0 and has become a -2. So as we look at this, we have to say who has gained electrons and who has lost electrons. So looking at magnesium first. Magnesium went from 0 to +2. Since electrons are negative, it lost negatives, which means it became more positive. So you have to think about this a little bit. But if you become more positive, that means you have lost negatives. You haven't gained negatives, or you'd become more negative. So we would say that magnesium has lost electrons. And we would say that the oxygen has gone from 0 to negative. It's gained negatives, so it has gained electrons. Now, a good way to remember oxidation and reduction is Leo says grr. So Leo is a big lion, and what does he say? Leo says grr. Now this stands for, is a little acronym, a silly little acronym that helps us remember that loss of electrons is oxidation, and if we take the grr, we'll get gain of electrons is reduction. So there's Leo says grr. So we had loss of electrons on magnesium, so it must be being oxidized, Leo, and oxygen was gaining electrons, so it's reduced, grr. So we say that magnesium is oxidized, and we say that oxygen is reduced. There's one more tricky part to this whole redox thing, and that is oxidizing and reducing agents. Now, let's think about this word agent for a minute. I'm going to write it out to the side here. An agent. What does a real estate agent do? A real estate agent sells properties, right? Do they generally, is the goal of them selling properties to sell it to themselves? Why no, it is to sell it to someone else. What about a CIA agent? He is going to go spy on somebody. Is he going to spy on himself? No, he's going to spy on somebody else. What about an IRS agent? Is his goal in his job to collect taxes from himself? No, it is to collect taxes from someone else. So an agent is operating on the other guy, right? That you can think of other agents, kinds of jobs that are called agents. A sports agent is trying to get big contracts or engagements for advertisements for the sports figure, not for himself. Recording agent is trying to get somebody a gig or a recording contract for the musician, not for themselves. So, although they're going to benefit too, but oh well. You've got the idea. The agent is doing it to the other guy. So the oxidizing agent is trying to oxidize the other guy, and the reducing agent is trying to reduce the other guy. So in order to oxidize the other guy, let's see, oxygen here in our reaction, oxygen becomes reduced. That means he gains electrons. That means he's taking electrons away from magnesium and causing magnesium to be oxidized. So our oxidizing agent here is oxygen. And our reducing agent is magnesium. So you'll see that because we're talking about what they're doing to the other guy, it's opposite of oxidized and reduced. Magnesium is oxidized, but magnesium is the reducing agent. Oxygen is reduced, but oxygen is the oxidizing agent. One of the interesting things about this is that when we talk about being oxidized and reduced, we just put the element, magnesium, oxygen. When we talk about the agent, we talk about the entire formula, the entire compound if we have a compound. In this case we don't, but at least we can put O2 to show that it is the whole oxygen molecule that we're talking about. So let's go on to the next equation and do our oxidation numbers. Copper is by himself, so it's 0. Then we move on to the next guy. We are always going to say +1 for hydrogen and -2 for oxygen, unless we have a good reason not to. And nitrogen, to take up the slack, has to be a +5. Copper here is not a 0 anymore. Now it has changed and become a +2 ion. The nitrate that it's with is going to be just like it was in the nitric acid, so that's still going to be a +5 and a -2. Then we get over here to nitrogen dioxide, and the -2 for oxygen obviously goes right in, and then the nitrogen to neutralize those two oxygens has to be a +4. And water has just hydrogen and oxygen, so that's pretty obvious. Now, who has changed? In most reactions, in most redox reactions, there are several elements that don't change, but there will always be two that change. One that is oxidized. In this case, it looks like that's copper, because copper went from 0 to +2. That's losing electrons, so that's the Leo part. And one other element has to be reduced. And so if we look through our oxidation numbers here, we find out who else has changed their oxidation number, and it's nitrogen. So nitrogen in this case has gained electrons and is reduced. In this case, we can look at this and say each copper atom lost 2 electrons. Since nitrogen is only moving from +5 to +4, there must be 2 nitrogen atoms that this is happening to, because you can't have extra electrons floating around afterwards. If somebody gains 2 electrons, somebody else has to lose 2, or 2 of them have to lose 1, or something to make the electrons balance. All right, so we would say now that copper is oxidized. And what else could we say about copper? We could say that copper is the reducing agent. As soon as we figure out that copper is oxidized, we automatically can say that copper is the reducing agent. It's the opposite. It's doing the opposite thing to the other guy. Now we would say that nitrogen is reduced. So we would also be able to say that nitrogen is the reducing agent, but wait, we have to name the entire compound. So we would say for the agents, we put the entire name. We would say that the nitric acid is the oxidizing agent. And I think the reason for this is because when we're talking about the agents, we're talking about what they would do to the other guy. So let's say I decide I really need to oxidize some copper. So who could I oxidize copper with? So I am going to go to my lab shelf and I'm going to look at my bottles and say, who up here is a good oxidizing agent? Who can I throw in with copper and copper would be oxidized? And so I don't ever grab a bottle of +5 nitrogen atoms. I grab a whole bottle of the nitric acid. So when you're dealing with agents, you're looking for someone who will do something to the other guy, and we need to find an entire compound that will do that. So we can figure out which compound to grab. Okay, Now let's do one last one here. We have some dichromate ion. In this case, we don't have a molecular equation. We have an ionic equation. We have some dichromate ion, and let's figure out what its oxidation numbers are. We're going to put a -2 for the oxygens, just like we always do, or almost always do. There's 7 of those. That's a -14. That has to add up to a -2, so we better have +12. Since there's 2 chromiums to share that +12, each one will be a +6. Now, onto sulfur dioxide, -2 for the oxygen, so the sulfur must be a +4. And the hydrogen ions, you see this charge up here for the hydrogen? Okay, that's what his oxidation number is. A simple ion has just his charge for his oxidation number. The same thing goes for the chromium ion on the other side. We have this 3+ up here, so we'll just put +3 down for his oxidation number. Then we have some sulfate ions, -2 for the oxygen, 4 of them, that's -8, has to add up to a -2. We need a +6. And then water, of course, is +1 and -2 because we have 2-to-1 ratio. Now, who changed? Okay, looking left and right, looking on the left side of the arrow to the right side of the arrow, we have the chromium. Chromium has gone from a +6 to a +3. That's a change, right? Is that in the oxidation direction or in the reduction direction? Is it Leo or GER? By the way, there's another acronym some people like better, which is OIL-RIG. OIL-RIG. And OIL stands for oxidation is loss, and RIG is reduction is gain. So if you like that one better, use that. In this case, we have chromium going from a +3 to a +6 to a +3. That's going in the negative direction on the number line, so we are being reduced. So this would be gain of electrons is reduction, or else we could say reduction is gain for RIG, whichever you like better. What else changed? We have to have 2 things that change. We always have a reduction and an oxidation. That's where the name redox comes from. They put the first part of reduction and the first part of oxidation together as one word to emphasize the fact that you never have one without the other. Somebody has to gain electrons if somebody loses them. And so we keep looking until we find that the sulfur has changed from a +4 to a +6. Notice we have 2 chromiums, each gaining 3 electrons. So if the sulfurs are going to lose 2, then we better have 3 of them doing it so that we have a transfer of 6 electrons. 6 gained, 6 lost. It doesn't have to be the same number for each atom, but overall in the entire equation it has to be the same. Okay, so that sulfur is losing electrons. That's Leo. So we can say chromium is reduced, sulfur is oxidized, and then of course we have to use the entire formula for our agents. So dichromate is what? The oxidizing or reducing agent? Well, if chromium is reduced, then dichromate is the oxidizing agent. It's oxidizing the other guy if it is being reduced. And then who is the reducing agent? Well, if sulfur is oxidized, then the sulfur dioxide is the reducing agent. Hopefully this makes the whole redox thing a little bit clearer.